Hello everyone, welcome back to the lecture. So now we will try to understand the calculation for the eccentric footing, right? So now what we'll do, I'll give you a small example now. Imagine that you have a footing, the size of the footing, the length, this is 1.7 meter, the breadth, and the length is 2 meter, it is mentioned here. We have a column, the size of the column is 300 mm by 400 mm. So it's a concentric footing. Your footing CG and column CG is matching. So let us say the live load coming is 300 kilonewton and the dead load is 200 kilonewton. SBC of the soil is 160. If you do the calculation, first we'll do the calculation. I mean, I told the other way around. First, okay, imagine that, I mean, not imagine, we'll start like this, okay. Okay, the load coming on your footing is from the column, 200 kilonewton is a dead load, 300 kilonewton is a live load, SBC is 160. For this particular load and for this particular SBC, what would be your footing size? We'll start with that. Very simple. 200 plus 300 is 500. We'll multiply this by 1.1 because self weight of the footing we need to add and divide it by SBC. You are getting 3.45. So 3.45 is the area of the footing that is required. To satisfy this, I have gone with a size of 2 meter by 1.7 meter. You can do that. Multiply 2 into 1.7. You will get 3.4. That is what I require here. Okay. This is for normal footing. Now, next thing what we'll try to understand. Suppose if I keep the size of the footing same. Suppose if I take the size of the footing same. And now if I make it as an eccentric footing, let me see what will happen. Like the footing size is same. I'm taking the same footing size which I've got it here, that is 2 meter by 1.7 meter. Instead of placing my column at the center, making it concentric, I'll make it eccentric and I'll keep my footing here. Now let me try to do the calculation, check whether it is able to take this particular load or not, this particular footing size. Okay. So for that, what all things is required? First is you have to find the moment that is coming, because see here your axial load is acting. From here, the eccentricity is created. That means it's something like this. This is a P load what is acting, and this is the eccentricity we have. Because of this P into eccentricity, a moment is getting generated. So how much is that moment? We have to find. So mxx is a moment along the xx direction. So P into E. What is P? 200 plus 300 is 500. So 500 is a load. Multiply by eccentricity is 0.8. How did I get 0.8? It was very simple. See, if this is 2 meter, this will be 1 meter. Very simple. Half of that will be 1 meter. Agree with me? Now, if this is 0.4 meter, so yeah, 0.4 meter, half of this means this much is 0.2. This is 0.2. I'll write 0.2 here. So I want from the center of this to here. So 1 minus 0.2 if I do, I'll get 0.8. That is why I've written 0.8 here. Do the calculation. So this will come out to be 400 kilonewton meter. That means because of that small eccentricity of 0.8 is a 400 kilonewton of moment which is coming on this particular footing. Now we'll do the calculation, which we know P by A plus M by Z. That calculation should be less than your SBC of the soil, and whatever is your minimum pressure, that should be less than the 0. I mean, that should be greater than the 0. So simple calculation will do. What is P? P is 500. So I've written 500. Multiply by 1.1 because of the self weight. Divide by area. Area I'm taking same. That is 1.7 meter by 2 meter I'll take. Just to make you an idea whether this footing size is sufficient or not. So that is why I've taken 1.7 into 2 here. Okay, fine. So then next is mxx, that is moment in xx direction. So, okay, how much is moment in xx direction? It is 400 kilonewton. So I written 400 into zxx. So zxx will be, see, this is your xx axis. So it is cutting your 2 meter. No, since it is cutting your 2 meter, you have to take the 2 square of that. So it's BD square by 6. So B is 1.7. So your D is 2 meter. So 2 square I have taken, divide by 6 I have done. So if you do this calculation, no, you're going to get 514 kilonewton per square meter. It's a maximum pressure. But we know that our maximum pressure should be less than the SBC of the soil. But our SBC is how much? 160. And I'm getting 514. That means it is not safe, right? As your pressure is 514, SBC is only 160. So it is not okay. Come to the minimum pressure. If you minus this, if you do this minus, you'll get 191, minus 191 kilonewton per square meter. We know that minimum pressure should be greater than 0, but in our case, there is coming minus. It means there is an uplift. What do you understand by minus? Minus means there is an uplift in your footing. That means your footing, because of this eccentric load, your footing is trying to act something like this way. yeah, I'll do like this. Suppose if this is a footing, okay, and if this is a column, okay, if column is like this, because of this eccentric load, because of the load and because of the moment, your footing is trying to behave something like this. Wait, let me do once again. Yeah, your footing is trying to behave something like this. So if this is your ground, if this is your soil, if this is my soil, okay, this much is my soil. Here, lot of pressure is getting generated. How much pressure is getting generated at this particular corner? 514. And here it is trying to lift up. You see, this is my soil, but it's trying to lift up. Okay, this much push it is trying to lift up. How much it is trying to lift up? That means the minimum pressure. Here it is. This value should be 0. If this value is 0, that means it is in contact with the soil. Now what has happened? It is minus 191. That means this uplift. Your footing is trying to lift. So will not allow this. So that means for that particular load, it is this particular size of the footing 2 meter by 1.7 meter is good enough if your column is concentric. But if the same column for the same load, if it becomes eccentric column, then this particular size is not sufficient. Understood the concept? That means now we'll go back to the one more thing. That means I'll go back now. What I'm basically trying to tell. So basically what I'm trying to tell is, give me 1 minute, just going back. Yeah. So basically what I'm trying to tell. So previously we had taken this footing, right? That means if you just increase the size, if you give the same footing here, it will not work out, right? If you give the same, that means I'll put it in a better way. Yeah, I'll put it in a better way. Wait. Previously what I had done, so your footing was something like this. No, then I told that half of that is going in the, wait, I'll change the color and it will make, it will be correct. Okay, I cannot change it. Okay, no problem. Okay, there's some problem with that. No problem. Huh. So, wait. So previously this was your footing size. So what I told, since your neighbor is not going to allow this much portion, I directly shifted it like this. But we already seen through the manual calculation, there is a difference between a concentric footing and a eccentric footing, right? For the same size, if your column becomes eccentric, this particular size of the footing is not sufficient to take care of the load. That we can see it through manual calculation. Now we'll tell, sir, why there is so much problem? You just increase the size of the footing, no? We'll increase. My size was 2 meter by 1.7 meter. I'll take a size of 4 meter by 4 meter. Take it like 4 meter by, wait. So you may tell, sir, why you're worrying so much? You just increase the size, no? If you increase the size, obviously it will pass. We'll do that. I'll take a footing size of 4 meter by 4 meter. Okay. Do the calculation and tell me. 4 meter by 4 meter. What will happen? First, you find this eccentricity. It will change now. Because now, since this is, try to understand the concept now. See, if this is 4 meter, half of this is 2 meter. So this will be 2 meter. If this is 2 meter, and if this is 0.4, if this is 0.2, how much will be this one? So it will be 2 minus 0.2, which will be 1.8. So this becomes 1.8. So if this becomes 1.8, try to do the calculation. 500 into 1.8. So it is 900. So this becomes 900. Okay. Your moment will be 9. Now do the calculation. You don't do. I'll do it. So quickly I'll do it here. See, P is how much? 500. That won't change. Into 1.1 divided by area. Area I'm taking 4 by 4. I'm getting 34. This answer I'm getting 34. 34.37. I'll take 35. I'll do plus. This portion I'll take. So what is mxx this time? mxx is 900 divided by, okay, this first I'll take 4 into 4 square by 6 I'll do first. Okay, I'll do this 4 into 4 square by 6. This will be 10.67. So 900 divided by 10.67 I'm doing. 10.67 I'm doing. So this is 84 I'm getting. Okay, fine. So how much is this? 84 plus 35 is how much? Plus 35 if I do, it is 119. So now it is safe, no? 119 is less than how much? SBC is 160. It is okay. We'll go with a minus 1 now. See again, this is maximum pressure. Come to the minimum pressure. So minimum pressure will be how much? 35. Exactly. Minus 84. How much will be? 35 minus 84 will be minus 49. but minus 49 is not greater than 0. So again, there is a failure. That means again, still there is uplift. Now you will tell, so fine, you again increase the size of the footing. No, you do it. Now I've taken 4 meter by 4 meter. You do it for 6 meter by 6 meter. Even if you do that also, you cannot satisfy. Quickly, shall I do for 6 meter, or let me take 7 meter and do? I'm taking a footing size of 7 meter by 7 meter. Let me check whether that 7 meter by 7 meter footing size is sufficient to take care of this moment or not. First, when I'm taking 7 meter, okay, I'll delete everything. No, I think I should delete all these things. These things I'll delete first, okay? I hope you are getting what I'm trying to tell. So basically my conclusion will be that whatever you do, you cannot satisfy this. That's it. That means you cannot satisfy this by increasing the footing size. I'll take a footing size of 7 meter by 7 meter now. So if I'm taking it 7 meter, if this is 7 meter, half of this will be how much? Exactly 3.5. If this is 3.5 and if this is 3.2, this becomes 3.3. If this is 3.3, you have to put 3.3 here. See, the moment you're increasing the footing size, the eccentricity is also increasing. See now, 500 into 3.3 is huge. You're getting 1650. You're getting 1650 kilonewton meter of eccentricity. Okay, now do the calculation quickly. So I'll do it. So this will be again 500 into 1.1 divided by, I'm taking 7 by 7. So I'm getting 11.22. So this will be 11.22. Okay, plus do this calculation. First, I'll do this section modulus. So 7 into 7 square divided by 6 I'm doing first, 57.16, and 1650 divided by this answer. I'm getting 28.86. 28.86. This is also fine, no? So add it, 28.86 plus 11.22 is 40, is 40. So 40 is less than 160. I'm okay. This is satisfied. Your maximum pressure condition is satisfied. Come to the minimum. So minimum, what will happen? Exactly this minimum. 11.22. What happened? Minus 28. So you tell me, since minus 28 is greater, obviously again this will be minus 11.22 minus 28.86 is how much? Minus 17. So again, minus 17 is not greater than 0. That means your minimum pressure is not satisfying. That means there is again uplift in your footing. You will tell, sir, take 10 meter by 10 meter. Even if you take 10 meter by 10 meter, also nothing will happen. The main reason is that this particular one is going to increase a lot. So what is the solution? Before coming to the solution, try to understand the concept. I'll put it in better way. That means even though you are increasing the size, if previously you had given this particular size of, let us say, 2 meter by 1.7 meter, even though you provide a footing size of 7 meter by 7 meter also, you cannot satisfy the minimum pressure criteria. Even if you give a footing size of 7 meter by 7 meter, you cannot satisfy the minimum pressure criteria. So what is the solution? The solution is that you need to connect this particular columns with a beam. So that particular beam, we call it as a tie beam, or few people call it as a strap beam. That means from this column to this column, I'll connect with a beam. So whatever eccentricity, whatever moment you're getting, 1650, 900, that will be taken by the beam. Understood the concept? So that is why, again, you see, this will be connected with the beams like this. So you might have seen certain drawings. I have shown you one drawing also in my drawing reading course, that there was something called a strap beam. So why this strap beam is provided? To take care of this, exactly, the uplift and all, because there is a huge uplift coming. So just by increasing the size of the column, it is not sufficient to satisfy. So we'll connect a beam. So this beam, what this beam will do, this beam will take this eccentricity. I mean, this thing, moment, whatever moment is coming, no. So this beam is going to resist that moment. Okay, because it's a moment. So beam is strong in flexure, so it can resist that particular bending. Okay, so that is the entire concept what I had explained you. Now for that, to support that, I'll show you one drawing so that you get an idea. Yeah. Now can you see this drawing? I think I had taken this particular drawing, and there also I had explained you all these things, but in depth I had not explained you there. So if you see all these footings now, you see your column is at the corner, footing is here, it becomes an eccentric footing. So we have connected a beam here. Same thing here, same thing here, same thing here. So this is how you are supposed to do. You will ask, sir, why it is not connected here? Because this is not eccentric footing. It's a concentric footing. My footing CG and column CG is matching. This is my eccentric footing. 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 Understood? So this was the entire concept of eccentric footing. One more question may come in your mind. So understood everything. But why you have given a beam in this direction? Why you have given a beam in this direction? Why the beam is not connected in this direction? Why this beam is connected in this direction? Why it didn't connect the beam in this direction? That is a question which is coming in your mind. So in the next lecture, we'll try to understand the possibilities of providing the beam, in which direction the beam has to be provided. Got it? So I'll see you back in the next lecture. Thank you.